This is kinetics number 10. This problem is a lot like 9, except for you notice this time when they're changing things, they're not changing the concentration of A, because we know we can change the concentration of A and not affect the equilibrium constant. But they're changing the temperature, and so this time we are going to see a different equilibrium constant. Equilibrium constants are always affected by temperature. So we're looking for an answer that will say the rate of the reaction is going faster and K is changing. So it looks to me like A is going to be the correct answer. The rate of reaction and the rate constant will increase. That should be true. You might wonder, could the rate constant decrease? And the answer is generally no. The rate constant increases with temperature, so definitely A should be the correct answer. In number 11, they're giving us a rate data table, and remember, a rate data table is required to find the orders for a reaction. And so we're going to compare this data and see what's going on. So I'm going to look at the experiments 1 and 2 where I can see that B is doubling in concentration. And the good news is A is constant, so we know that the entire impact will be because of B. So as B doubles in concentration, you notice the rate also doubles. So that's a first order reaction. If we had doubled the concentration and the rate had gone up by 4 times, that would be a second order reaction. So it's definitely going to be first order in B. So keep track of that. Now let's look at A. Well, A, I would like 2 experiments where B is constant. So I'm going to compare experiments 2 and 3. And you'll notice A doubles, and the experiment has no change in rate. That tells us that the order with respect to A is 0. So we are looking at the answer being C, because C is the only one that doesn't have A in it. Number 12, we've got a reaction up here and we've got a rate law. And the first thing we'll notice is that B does not seem to be impacting the rate. So whatever they ask us down below, we know that doubling the concentration of B is not going to do anything to the reaction. Now that doesn't mean that B isn't important. You do have to have B to do the reaction. The thing it's telling us is that B must do whatever it does after the rate limiting step. So maybe in the first step B isn't involved, A just becomes C, and then in the second step B does something, but it's after the rate limiting step. So if we look at our choices, they want to know which of the following will increase the rate of the reaction. An increase in A, you better believe it. It's in the rate law. If we double A, it will double the concentration. B, nope, that's out. C, an increase in temperature is likely to increase the rate of the reaction because they're colliding. And the other thing to remember is if you increase the temperature, you also increase the rate of the forward and the reverse reaction. So we're not going to affect the equilibrium, but we will make the reaction reach equilibrium faster. So I like 1 and 3, and that looks like the answer is C.